Welcome back to the Deep Dive. Today, we're plunging into a topic that's absolutely vital in our interconnected world, network security. But instead of just a broad overview, we're taking a really unique angle for this deep dive. We're going to use the NetSec-Pro exam as our lens. Think of it like a focused spotlight, cutting through all the complexity to reveal precisely what's most important in securing our digital lives.
That's exactly right. And looking at practice questions from an exam like NetSec-Pro, well, it isn't just about getting the right answer. It's really about extracting the distilled essence of real-world challenges. These questions, they're carefully crafted scenarios. They highlight the most critical concepts, the practical dilemmas network security pros face every single day. Our goal here is to go beyond just memorizing facts and instead really uncover the strategic why behind each solution. That gives you, the listener, truly actionable insights.
Right. So our mission for this deep dive is pretty clear then. We're going to unpack key concepts, everything from, you know, firewall fundamentals, right up to cutting-edge threat prevention, modern network management, essential troubleshooting techniques. And every insight we pull out will be drawn directly from the practical wisdom baked into these real-world exam scenarios. We promise we'll try to make even the dense stuff engaging and, most importantly, easy for you to grasp. All right, so before we dive into specific defense mechanisms, let's maybe zoom out a bit. Imagine your network is like a sprawling city. What are the core departments keeping it running smoothly, keeping it secure? The NetSec-Pro exam really does lay out these foundational pillars of network security quite nicely.
It does, yeah, it's very comprehensive. The core topics covered include things like firewall fundamentals and architecture, obviously. Then there's policy configuration and management, network address translation, you often hear it called NAT, and routing. Also user identification and authentication, threat prevention, intrusion protection, logging and monitoring. And finally, device management and troubleshooting. Taken together, these categories really do encompass the entire spectrum of what it takes to secure a modern network, from the edge right down to its core.
Okay, let's start with what sounds like the command center, a
Mhm.
crucial role of centralized management systems. Imagine you're a network admin, right? You're managing this huge network, maybe hundreds of devices. There's a specific critical order you need to follow when updating your systems. So our first scenario, this is drawn from question 1. It asks directly, which component must be updated first to ensure successful PAN-OS upgrades in a Panorama-managed environment?
Right, and this immediately brings up the concept of panorama upgrade compatibility. The absolute key here, the thing to remember, is that Panorama, being the brain, the centralized management for your firewalls, must always be updated before any of the individual firewalls it manages. See, if your Panorama version falls behind the firewalls after they upgrade, you risk more than just compatibility headaches. You could actually blind yourself to threats, or even lose the ability to manage those firewalls entirely. It's kind of like the network's nervous system needing to be perfectly aligned for the body to function properly. It ensures you have consistent features, consistent configurations across every single device under its control.
Okay, that makes perfect sense. Panorama as the central brain. Got it. But it's not just for your on-premise devices anymore, is it? How does Panoramic extend its reach into those dynamic cloud environments, the ones that are always changing? That actually brings us nicely to the insights from question 6.
Yeah, and what's truly powerful here is how Panorama bridges that gap, between traditional infrastructure and the cloud. It serves as that centralized management system, allowing administrators to effortlessly configure and manage cloud NGFW instances within environments like, say, AWS. And this means you can leverage the same familiar interfaces, the same policies, the same operational workflows you already use for your physical firewalls. That dramatically simplifies what could otherwise be incredibly complex cloud deployments, and it ensures policy consistency across these hybrid environments.
So it really crystallizes the idea then. Panorama isn't just about managing individual boxes. It's about ensuring a cohesive, harmonized security posture across your entire digital landscape, from your data center right into the cloud. Okay, now let's talk about the relentless fight against cyber threats. One of the biggest puzzles for me, thinking about network security, is protecting users who are outside the traditional office walls. How do these sophisticated systems even begin to tackle that challenge, especially with threats evolving daily? Question 2 dives right into Prisma Access and how it handles mobile user traffic.
That's a critical challenge, absolutely. And Prisma Access threat prevention is really purpose-built for those mobile workforces. Think about like an executive connecting from a coffee shop or maybe an engineer working from their home network. Two crucial features immediately come into play there. First, URL filtering. That intelligently blocks access to known malicious websites based on categories or live threat feeds. And second, the antivirus profile, which diligently scans all their traffic for known malware signatures. Both are absolutely essential for securing users when they're outside the corporate perimeter. It stops them from accidentally bringing threats back into the network.
Right, okay, so that addresses known threats, which is vital, definitely.
Hmm.
But how do these systems find threats no one has ever seen before? The truly novel ones, the zero-day attacks. Question 4 tackles that, the real cutting edge of threat detection.
Ah, yes. This is where Wildfire really comes into its own as a security service. It's fundamentally about anticipating malicious intent, not just reacting after the fact. Wildfire uses a combination of sandboxing and machine learning. It analyzes the behavior of unknown files in a secure virtual environment. So if a file acts suspiciously, even if it doesn't match any known signature, Wildfire can identify it as a threat. This means your defense isn't just reactive, it's proactively building this sort of collective immune system for all connected devices globally. Wildfire learns from every new threat it sees and instantly shares that intelligence across the entire ecosystem. It turns every individual detection into a universal defense.
Wow, that's incredibly powerful for catching the unknown. Seriously. But what about stopping ongoing attacks? What if malware has potentially already infiltrated a system? Question 8 gives us some insights into how these tools prevent further damage in that scenario.
That's precisely where the anti-spyware profile takes over. Its primary mission is to detect and prevent command and control traffic, C2 traffic. This is that covert communication channel malware uses to phone home to attackers, for instructions or maybe to exfiltrate data. By leveraging DNS signatures, these are unique patterns in DNS lookups that point to known malicious C2 servers along with comprehensive threat intelligence. It effectively blocks access to those malicious domains. It severs that crucial lifeline for the malware.
What really jumps out at me here is how it's clearly not about finding one silver bullet solution, one thing to kill all threats. It's much more like a highly trained special forces unit. Each member has a specific role, and they work in perfect sync at every stage of a potential infiltration.
That's a great analogy. It really is layered defense.
Okay, now, let's talk about inspecting traffic that's encrypted, which is, let's face it, almost everything these days. This often feels a bit like magic, but I know it's quite deliberate. So first, let's look at when and how to decrypt. Question 3 covers this, comparing SSL forward proxy and SSL inbound inspection.
Yeah, understanding these SSL decryption modes is absolutely crucial for modern network security. You have to get this right. SSL forward proxy, that's used specifically for outbound traffic, so internal users accessing external HTTPS websites. Here, the firewall acts as a transparent intermediary, like a proxy. It decrypts the traffic, inspects it thoroughly for threats, and then re-encrypts it before sending it on. In stark contrast, SSL inbound inspection is designed for incoming HTTPS traffic, usually traffic destined for your internal web servers, protecting your services from external threats. Two very different use cases.
Okay, clear distinction. So following up on that outbound piece, what are the absolutely essential components for configuring that outbound SSL decryption? Question 5 gives us the practicalities.
Right. For successful SSL decryption configuration of outbound traffic, you fundamentally need, two main components. You need a forward trust certificate and you need a decryption policy rule. The forward trust certificate is what the firewall uses to re-encrypt the traffic after it's inspected. And it's critical that your client machines, your users' computers, trust this certificate. Otherwise, they'll get errors. Then, the decryption policy rule is where you define exactly which traffic you actually want to decrypt. Maybe not everything needs it. Without both of those pieces in place, outbound SSL decryption simply won't function correctly.
Interesting. But decryption isn't always smooth sailing, right? I know it can be a real hurdle sometimes for administrators. Question 10 brings up a pretty common challenge. Why does decryption sometimes just fail for certain sites?
Yeah. This points directly to SSL decryption limitations, and specifically a security mechanism called certificate pinning. Think of it like a prearranged trust agreement. A client application, maybe a web browser for a specific banking site, or a particular mobile app. It's basically hard-coded to expect a very specific certificate from that website or service. Now, if the firewall, acting as that forward proxy, replaces that expected certificate during decryption with its own perfectly legitimate proxy certificate, well, the client application sees it as an unauthorized change, a potential imposter. It will then reject the connection outright, and boom, decryption fails for that site. It's actually an incredibly strong security feature, makes it hard for attackers to spoof websites, but it definitely creates this necessary friction point between deep security inspection and how end clients build trust.
Right. So it's clear then, decryption is powerful, maybe essential for deep inspection, but it's kind of a double-edged sword. It has its own set of fascinating challenges and rules you have to play by. Okay, let's shift focus slightly. How do firewalls understand what's inside the traffic? That brings us to question 9. How do they identify applications, especially when applications try to hide on non-standard ports?
This is where App ID technology comes into play, and honestly, it's a game changer for granular security policy. Instead of just looking at port numbers like older, less intelligent firewalls might do, App ID deeply inspects the session's actual payload, the header information, even how it behaves over time. It can dynamically identify applications regardless of the port they're using, the protocol, or even if the traffic is encrypted, obviously, it deciphers it after decryption. And this lets firewalls enforce very specific, very granular policies based on what actual applications are being used, not just what port they're on. That's absolutely critical against evasive applications that try to hide by using common ports like port 80 or 443 for non-web traffic.
Yeah, makes sense. Very clever. Okay, finally, let's talk about how network policies can be smarter, more flexible, especially in these fast-changing environments like the cloud. Static rules just can't keep up, can they? Question 7 gives us a key insight here.
That's exactly right. Static rules become a management nightmare in dynamic environments. This is where the concept of dynamic address groups, or DAGs, truly shines. DAGs use tags or metadata think labels to dynamically include or exclude IP addresses from a group. This means your firewall policies can update automatically, basically in real time, as group membership changes. So this provides incredible agility in highly dynamic settings, like cloud deployments where virtual machines are constantly spinning up and down, or maybe with mobile endpoints whose IP addresses change frequently. It allows your security policies to be as fluid and responsive as your network itself.
That fundamentally changes how you think about firewall rules, doesn't it? It transforms them from these static, brittle lists into dynamic, adaptable groups that respond automatically to the ebb and flow of your actual network.
Exactly. Much more manageable, much more effective.
As you, our listener, think about how quickly new threats continue to emerge and how our work environments keep evolving with cloud and mobile, here's a thought. What do you think is the next major challenge these security professionals will need to overcome? And how might these already advanced tools continue to adapt, maybe in ways we haven't even thought of yet? Something to mull over. We look forward to exploring more with you next time on another Deep Dive.